All right. Afternoon, everyone. How's it going? Well, first of all, I'd like to say thank you for coming to learn about what's happening in the Java ecosystem instead of going to the start of the pub crawl, which is in 30 minutes. Or actually, I didn't say that. So my name's Kyle Thompson, and this is Sam Fink, and we're both engineers on the AWS SDK and tools team. So we're the team that kind of vends both the SDKs and a lot of the client-side tools that people use as part of their development process. So Sam focuses mostly on the SDK side, in particular the Java SDK and some of the higher-level libraries that sit on top of it. And I'm mostly on the tools side, so IDE integration, stuff like that. OK, so for those of you who came to my session last year, I did a session at reInvent last year on the Java ecosystem. You might remember this diagram, or a diagram that looks something like this with colors that are a little less ugly. This is kind of a broad brush of the things that AWS does that are specific for Java developers or for the Java ecosystem. So there's client-side tools. There's kind of execution environments like AWS Lambda that have Java-specific variants. Now, we're not going to talk about all of this stuff today, so I'm going to just kind of condense this down to the areas that we're going to focus on. We're going to look a little bit about streaming and some things we're doing in that area. We've got some client-side build tools to look at, the SDK itself, and then a new execution environment. So the first thing we're going to talk about is in the client-side build tools arena. So we've had an Eclipse toolkit for many years now. There are a number of third-party JetBrains plugins available, but until recently, there was no officially supported AWS toolkit for JetBrains. And so that's what I'm going to talk to you about today. First up is our toolkit for JetBrains, specifically for IntelliJ. So first up, I want to talk a little bit about why we're doing a toolkit for JetBrains. Can I get a show of hands? Who uses IntelliJ as their main IDE? OK, cool. Well, that kind of makes this slide a little redundant, because I think it's obviously very popular, and we like to meet customers where they are at AWS. So Java developers are using IntelliJ as their IDE of choice. It makes sense for us to kind of build into that ecosystem. But the beauty of the JetBrains platform is that it's not just IntelliJ. So PyCharm is also a super popular IDE in the Python space. And they have a really broad ecosystem of a number of other language-specific IDE environments. And by building a JetBrains toolkit, a generic JetBrains toolkit, we can hopefully take advantage of a lot of those other languages there as well. At the moment, we're focused on IntelliJ and PyCharm, but we've built it in a way that we can extend it out to other languages as well. So currently, where we are is a developer preview. We do have an early access channel available on the JetBrains plugin repository, but you can't actually download it from there right now. That's going to be something we enable later in the week. But you can build from source. So I'm going to take you quickly through how we do that. It's just a matter of cloning our repository and running a Gradle command. I've got a video here that kind of takes us through that process. Like I say, clone the repository, and then we're just going to run a Gradle build plugin. JetBrains vends a Gradle plugin for actually constructing an IntelliJ or a JetBrains plugin, which includes kind of bundling everything up and creating your plugin XML and all the kind of details that you need to be able to tell the IDE how to find those features. Now, I've sped up this video because we don't want to all sit here and wait for 2 minutes while it happens. But once that build is successful, you'll get a zip file that gets put into a build directory. So then it's just a matter of going over to your IDE, going into the plugins pane, and then choosing to install the plugin from disk. Now, if you're in an older version of IntelliJ 2018.2 or before, the plugins pane might look slightly different, but the process is going to be the same. It's that install plugins from disk, and then you'll get prompted to restart. And at that point, you'll have the toolkit installed. So let's go and have a look at a quick demo of what this thing looks like in IntelliJ. OK, so what I've got here is IntelliJ Community Edition. The plugin works with both Community and Ultimate editions of PyCharm and IntelliJ. And what I've got here is kind of the regular start screen that you get when you fire up the IDE. Now, the toolkit's already installed and configured, so I'm just going to go to New Project. And what I get is this new AWS serverless applications project type that we're gonna kind of step through today. So I'm just gonna hit next. From here, I can pick from a number of templates that we ship with the toolkit. Now, what I should have mentioned was the toolkit relies on the AWS SAM CLI. Who has used SAM or the serverless application model before? OK, great. So the SAM CLI is a client-side tool that you install in your developer machine that enables you to run and debug Lambda applications or serverless applications locally on your machine. And the IDE is really delegating a lot of the heavy lifting down to SAM so that you can get a similar experience in the IDE as you would if you kind of executed some of those commands at the command line, maybe as part of a CI/CD process or something like that. So these templates are templates that SAM provides for us, and we intend to kind of expand this list over time. But I'm just going to create a Hello World one for now. Give it a name. Awesome. Let's try that again. All right. I think it's because I didn't clean up before the demo properly. OK, so what that's done is that's invoked the SAM CLI init command and created me a serverless application for Java. Now, this is just a Maven project. So IntelliJ has detected that there's a POM file here and helped to resolve my dependencies. And the kind of magic that makes this work with serverless is this serverless template that gets created here. So you'll see the toolkit has marked the serverless function there with a run icon, and that's something that we're going to come back to. But it's also the init process has created for me an application.java, a class that extends Lambda's request handler here. So the toolkit, again, has kind of inspected the AST here. And by virtue of the fact that we're implementing that handler or that interface, we can infer that this is probably likely to be a Lambda function. And so we show this, what IntelliJ calls a gutter icon, with the Lambda symbol. And from here, you have a number of options that you can do. And we're going to look at some of those in just a minute. So I'm going to jump back to the template here. And I'm actually going to run this thing locally. So when I hit run, that pops up a regular kind of IntelliJ run configuration dialog. And from here, you can configure the inputs to your function. So you've got a few ways you can do that. You can select from file, and that will be a file that every time you invoke the function or the run configuration, we're going to load up from that file. So if that's something that gets checked into your project, it's going to update every time you invoke. You can manually insert input here as part of a rich JSON text editor. So we hook into IntelliJ's ability to present JSON documents. So it's going to tell us that, hey, this isn't valid JSON. Lambda's going to expect you to send in a valid JSON document. And so you get the ability to kind of get that help as you're creating the inputs. And then similar to our other toolkits and the AWS console, you have the ability to pick from a number of kind of pre-canned event types here. So our hello world function doesn't really actually care what the input is. So I'm just going to pick one of these at random, maybe not random, hello world, since it's a hello world function. And I'm going to hit run here. And what this is going to do is it's going to package up my application into a zip file that Lambda understands. And it's going to hand it over to the SAM CLI. The SAM CLI is then going to spin up a Docker container for me that looks like the Lambda runtime environment on my local machine. So it's running the same architecture that you would run in Lambda. It's a very, very high fidelity environment. It looks a lot like Lambda and acts a lot like remote Lambda. And then we're going to invoke that function with the input that I specified, and we get the response back out to the command line. So that's a basic local invocation. But what we really wanted to add, and what customers have been asking us a lot for, is the ability to actually debug locally. Now, SAM does provide the ability to debug locally today outside of the IDE, but it involves several steps of kind of spinning up the Lambda and then opening up a port, coming back to your IDE manually and attaching to that port. What we've done is we've kind of simplified that process here. So I'm going to set a breakpoint in my code, and then using the same run configuration that I used a moment ago, I'm just going to click the debug icon instead of the run icon. And this time, it's going to do the same thing. It's going to package everything up into a zip file, hand that over to SAM CLI. But SAM CLI is going to actually open up a debug port, and the IDE is going to attach to that debugger. Now, at this point, we are in a regular IntelliJ debug process. So who's debugged a Java function in IntelliJ before? OK, so this is hopefully pretty familiar. You can kind of step through. You can step into things. We can inspect variables. Anything that you'd expect to be able to do as part of a debug session, you can do locally against a Lambda-like environment without having to leave your machine. So I'm going to let that run through. And again, we get the output put out to the console there so that we can see what's going out. Now, in terms of my development lifecycle, so far I've created a new application. I've maybe made some logic changes to it. I've run that locally. The logic is doing what I expect it to do. I've debugged stuff, so I'm kind of confident what's going on here. And now I want to actually deploy this thing. So again, from the create menu, from the gutter icon here, I'm going to go create new AWS Lambda. And this is going to pop me up a create function dialog here. So I'm going to give my function a name. I'm going to set some variables here, so we'll give it a gig of memory. I'm going to create a new IAM role for it. So the toolkit is, that create button is going to create me, or give you the option to create an IAM role with kind of the minimum set of permissions that Lambda requires in order to be able to assume the role and for you to be able to do things like write to CloudFormation logs. So I'm going to give this a name. And then that gets automatically selected. Now, I've just gone ahead and done this in Sam's account accidentally, because what I didn't do was switch my profile. So one thing I should have mentioned before was we have this ability to kind of attach your session to a particular AWS connection. And that is from this menu in the bottom right-hand corner here. So from here, I have all of the credential profiles that have been loaded from my local credential file. Now I'm going to switch accounts here to a reInvent account that I kind of created to be able to do these demos. I'm going to change to US West 2. And at this point, my toolkit is configured to use those parameters for any remote operations that it does, so including things like creating new Lambdas. So let's go back into my create dialog here. And I'm going to give my thing a name. Give it its memory again. Create an IAM role. I'm going to create a new bucket, which is always dangerous because S3 has a global namespace, and someone might have stolen this from under me. But hopefully, this is unique enough. Yay. And then I'm going to hit create function. And again, what this is going to do is create a zip file, put it in S3, and then call out to Lambda and tell it to use that as a source and create the function with the configuration I specified. So that has now been deployed remotely. Now if I jump across to the AWS Explorer, so it's a new tool window that you get that by default is pinned to the left-hand side, I have something that if you've used one of the other toolkits before, you might be familiar with. It's kind of a remote resource view. So this is a hierarchical view of the resources that I have in my account. Now, at the moment, you'll notice it's pretty limited. We only have Lambda and CloudFormation in here. And our reasoning behind that is we want to make sure we're showing resource types that you have some ability to actually interact with in the toolkit. It doesn't make a whole lot of sense to list off all your EC2 instances if you can't really do anything with EC2 instances in the toolkit. So we've made a very conscious decision to add resources to this list as we add features that relate to those resources to the toolkit. So I'm going to right-click on my function here, and I'm going to hit run. So this is, again, going to pop open a run configuration dialog, similar to the local one. This time, it's fewer options because a lot of these options are kind of baked into the Lambda definition. And I really just need to specify my input here. So once again, I'm going to select the Hello World option, hit run. And this is going to do a remote Lambda invocation and give me back the result to the console. So from the remote view here, there's a few other things I can do. Sam's going to take us through the update function. Well, I guess you don't really execute it, but we're going to see that in a minute. But one of the coolest things, I think, for this is the ability to actually jump to source. So it's not necessarily that impressive in this small project where I only have a few class files. But if you can imagine a project where you had dozens of Lambdas and a large project structure, then the ability to jump from a remote Lambda to the local code that actually drives that is kind of cool. So by clicking jump to source here, what the toolkit is doing is applying some heuristics to the handler and then trying to find a class and method name that matches that handler in the local workspace and then bringing that thing into focus. So you've got the ability to navigate from your remote functions to the local code that actually drives them. So that's kind of the broad brush features of the toolkit in IntelliJ. Let's switch back across here. So you'll see from that we've focused largely on serverless, so AWS Lambda functions and interacting with them, being able to debug them locally, creating new serverless projects, and then being able to kind of deploy those and invoke them remotely. Like our other toolkits, we have the ability to do basic resource management, credential management. We saw that credential switcher and the region switcher, so you can tie your IDE session to a particular AWS connection. And coming soon is the ability to actually deploy a serverless application. So when we created the new project, a template was created. This was a serverless application model template, a SAM template, which is basically a superset of CloudFormation. And so what we're going to add very soon is the ability to use CloudFormation to actually deploy both your function code and the associated resources that you defined as part of that template. That is a feature that we have in the PyCharm version of the IDE. We're still working through the Java build to get that feature included in IntelliJ.
Yeah, so everything you demoed there is available in PyCharm
yes.
as well today.
That's right. So all of that stuff that we demoed here is available in PyCharm as well. The only thing missing from IntelliJ that is available in PyCharm is the deployment of an application. So like all of the tools that we're going to talk about this afternoon, this is open source. But we're doing things slightly differently than we have done other open source projects. And this time we've actually open sourced a lot earlier than we normally would. We open sourced about 3 or 4 months ago, long before we had kind of a minimum viable product. And we wanted to do that so that the community had a chance to give us their opinions and work on the code before it's completely polished and try and build up that community. We're also doing all of our project management stuff completely in the open as well. So we're using GitHub's project features and their milestones. So what we're hoping is that, and by giving talks like this, that we can kind of encourage the community to come and help us out, help us prioritize things, raise feature requests, submit code, and try and make the toolkit better. We've actually worked pretty closely with JetBrains. If you go across to the GitHub repository, you'll see they've actually made some contributions to it already, which is pretty awesome. And I guess just while we're talking about JetBrains, a quick plug. They have a booth in the Tools Fair. Recommend you go along to that. I have a handful of, or a few of their trial, 3-month trial, or product packs things if you want to come see me afterwards to kind of help you get started on one of the more ultimate editions. So that's the AWS JetBrains toolkit. I'm going to hand over to Sam to talk to us about the SDK.
Hey guys, so yeah, like Kyle mentioned, my name is Sam. My primary focus is on the AWS Java SDK. How many people out there have used the Java SDK? Yeah, quite a few of you. Yeah, so if you're a Java developer, you like using that. Even all the stuff you saw in the toolkit, all that interactions with the Lambda function, right? That's using the SDK under the hood. So if you look at this, back to this ecosystem overview here, right there in the middle, we've got the AWS Java SDK because it kind of is that piece that connects all of it. And so the AWS Java SDK was actually released in 2010, so about 8 years ago now. It was the first official AWS language SDK to be released. And I don't know how familiar you are with your Java history, but Java 7 didn't even come out until 2011. So we're actually baselined all the way back on Java 6. And so still today in 2018, we have that Java 6 baseline. All the interfaces that we wrote in 2010, including limited functionality like no function code, no diamond operators even, that's all. We have to maintain backwards compatibility all the way back to then. And then since 2010, we've actually had 7 other official AWS language SDKs. And in that time period, all but the latest has done at least one, if not multiple new major versions. So the Java SDK is kind of lagged behind there. We've been really restricted in what we can do. But officially, as of last week, we did GA the AWS SDK for Java v2. So this is a complete new major rewrite of the SDK from the ground up. And that's what I'm going to go over here today. So Kyle was here last year, as you mentioned, and he kind of briefly went over the Java SDK v2 developer preview. Late last year, we went into developer preview, and then since then, we've been working towards our GA of last week. And so when working on the SDK, because we've gotten a lot of feedback over years in our v1 repo, because that's been available for those 8 years as well. And so we've gotten a lot of feedback. And so going into this design, when it came to our coding interfaces, when it came to how you guys would interact with the SDK, we had 3 really big tenets that we wanted to hit. The first was, as you see here, non-blocking asynchronous service clients. So in v1, you might have seen that there's an async client, but that's actually just a thread pool on top of the synchronous client. It still used Apache's synchronous client underneath the hood. So you couldn't really get that high concurrency that you can get in a fully non-blocking asynchronous world. So whereas now in v2, let's say you're using a service like SNS, you could see there for any service it's going to have an async client. And you could just call that create method. And what that create method is going to do is similar to v1, the default client method. It's going to create the client with all of what we think is good defaults for you. It's going to detect your region automatically. It's going to detect your credentials automatically. It's going to create that netty client with a default number of connections and settings that we think is best for you. But as you'll see in a second, you'll also have access to that builder method to if you want to do more configuration there as well. But that is a fully non-blocking asynchronous client built on top of netty right now. And then so as Java has evolved, more and more we've moved into immutability as a pattern in Java. And so we want to make sure that to maintain thread safeness, to make sure your objects aren't getting mutated without your knowing, we wanted to make sure everything in the Java SDK v2 is immutable. So all the clients, all the request objects, any Java POJO is going to be immutable, and you can use the builder pattern to create those objects. So again, going back to the synchronous client here for SNS, you'll see that builder method, and then you can set the region there, you can set the writer, and stuff like that. What you notice here on a difference for that profile credentials provider, it does have that create method there. And so again, when you're working with objects that we think have assigned defaults, like in this case, if you just want to read that default profile, we have that create method, so you don't have to call builder.build to just to pass no settings. So if you see that create method, know that there's likely good defaults, but you can also change it if you want. One of the things you also might notice is we don't use the with or getter setter pattern that you see a lot of in Java. Java as it is can be quite verbose. Even more so when you go with immutability. So we kind of pair those off and go with the succinct, just method names, region, credentials provider. We do provide a serializable bean interface, though. So if you do want to serialize or deserialize objects, we do have those getters and setters if you're using the bean spec. And then the last big tenet we had was having pluggable HTTP clients. So in v1, we just had Apache as our HTTP clients. And you couldn't plug in any client you wanted. So if you're using something like Android or you were in a Java ecosystem that either required or strongly suggested that you use a specific HTTP library, you either had to ignore that device or download our source from GitHub and manually hack it in yourself. Whereas now in v2, you can do something like this. We provide a set of interfaces. You can implement those interfaces and then plug that straight into any service client. In this example here, you can see we are using the URL connection HTTP client. We do provide that out of the box as well as an option for if you're in the synchronous use case. And we've actually already seen some pretty good community support here too. Even before we GA'd, a user, a Scala guy, likes to use Scala, so he used and implemented the Akka HTTP library as well. So you can already use that. If you're a Scala user, you can already plug that straight into our SDK and get that Akka client. And then, so just kind of, as you can see when you went through all this, Java kind of gets verbose in general. And so as much as possible, now that we have access to functional programming paradigms, we introduced a consumer builder pattern. So whereas, if we didn't have this option, you can see here Java gets kind of verbose. Let's say you want to set an API call timeout. You have to call this client override configuration. You have to call builder on that, set the timeout, then call build. So it's quite verbose. Whereas with the consumer builder pattern, you could do something as simple as this. That override configuration only takes in a client override configuration object. So there's no reason that we can't just create that for you under the hood. You can set that timeout. You don't have to call build, and we're going to automatically build that object for you. So those are our three big tenets as far as our coding interfaces go. And then again, one of the other big areas of feedback we've gotten over the years is related to a specific execution environment, and that's AWS Lambda. And what we wanted to focus on in V2 was how do we get the best Lambda experience within the SDK? And in particular, we've received feedback from customers over the years that our startup time is not where we want it to be with V1. But again, like I mentioned earlier, we maintain backwards compatibility. This SDK was created in 2010. And so there wasn't really a lot we could do to improve that SDK startup time without breaking backwards compatibility. And so before we go into a demo to see what that improvement looks like, you don't necessarily get the best Lambda experience out of the box because there is a clear difference between that short-lived Lambda type environment and a long-lived EZ2 environment. And so we want to make sure, if you're using Lambda and using the SDK v2, that you do the right things to get that best experience. That includes using the URL connection as the HTTP client. By default, we do use Apache because you can get that high concurrency. It is more configurable. But if you're running in Lambda where you don't need thousands of TPS, we recommend that URL connection client because it's built into the JDK, it's lightweight, and in all of our testing, it allows you to do everything that you can do with Apache and Netty, just without that high concurrency. It's basically your one hit. We moved off Jackson Object Mapper at runtime, and in general, we moved off all class path scanning at runtime and moved to generating resources at compile time. So I don't know if you know, but we have this large endpoints file in V1 SDK that basically includes metadata for all of our services, metadata for all of our regions and partitions. And we were reading that at runtime. It was taking in a Lambda function, you could take up 10 seconds just to read this endpoints file. So now we actually generate those resources at compile time. And it actually also gives you free access to those objects. Because they're now just plain old Java POJOs, we've got much richer region metadata. We've got much richer service metadata available to the SDK, available to you guys to use. And then one other quick note. So we use JMH. We use YourKit to do the profiling, both on our local Macs and on Lambda. And so one of the things I want to mention, just I thought it was interesting, is when you new open Apache client, which is our default client for synchronous, it gives you an option to set a user agent. If you don't set that user agent, it's actually going to, again, scan your class path to try and find a user agent file on your class path. And we actually, when we were testing that on our Macs, that actually took about 100 milliseconds just to do that lookup. And in the SDK, we actually set the user agent for request. So it was actually spending 100 milliseconds that was just ultimately wasted because we don't use it. And when you're talking about a Lambda function that runs in a second or 2 seconds, that's 5 to 10% of your runtime just spent on this useless lookup to us. So let's take a look at what this looks like in the new SDK. OK, so you can see here, so this is an SDK. This is an example. It's using our V1 code base here. So it's creating a simple DynamoDB client in USEs2. And I'm going to call list tables and just print out the first table. Same thing here. So now in our V2 client, again, we're using DynamoDB. Again, we're giving it a region. But like I mentioned earlier, we're passing it that URL connection HTTP client. So we're going to use that URL connection client under the hood. And again, another good thing you can do to help out Lambda is, Lambda provides your region and your credentials as an environment variable. So if you tell a Lambda, hey, if you tell the code base, hey, use that environment variable credentials provider, it's not going to waste time looking for those details somewhere else. And again, here, I'm just going to call list tables and list out the first table name. One quick thing to note, because we see this a lot, even internally and externally, is when you're using Lambda, you can define resources outside of that request handler method. And so always make sure you're defining the SDK, and like in this example, outside of this handle request method. If you create this client in that handle request method, you're going to take that startup time hit on every invocation of a Lambda function. Whereas if it's outside there, that's going to be alive for the life of that container, which is perfectly fine because we are thread safe, we are immutable.
So this class only gets newed up on container start?
Yes, exactly. So I'll quickly just show you the configuration here using the toolkit. They're both set to 1 gigabyte. They got a 60-second timeout, but that's not super important for this. And I'm going to go ahead and run this remotely. Usually takes around 1.6 seconds, 1,600 milliseconds here. So you can see here, OK, so this is actually a little bit faster, but about 1,400 milliseconds there. And you got my bucket, and you used 116 megabytes of memory. Whereas now, if you run the V2 one, this usually completes in around 600 to 700 milliseconds. Again, so there we go, 643 milliseconds. So again, exact same code, doing the exact same thing, but that's over a 50% improvement right there. So we're really happy now with where we're at. And going forwards, whereas in V1, because we couldn't make the improvements that we wanted to make, it wasn't as important to us that we continued to monitor that startup time. Whereas in V2, it's part of our process. We're going to continue to make sure that if we're not continuously making the startup time better, we're going to guarantee to you guys, we're not going to make that worse as we continue to make updates. So what else is new in the AWS Java SDK v2? So we are modularized. Unfortunately, we are baselined on Java 8. We did want to baseline on Java 6, but as many of you guys are aware, Java recently switched to that 6-month release cadence. And whereas Java 9 was going to be a long-term support version, they instead changed where Java 11 is that new long-term support version. And because we want to meet customers where they are, we are baseline on Java 8 because we haven't seen that migration to 9 or 10 or more importantly, that new 11 version that came out 2 months ago. But we are still modularized. We do have full support for 9, 10, 11. We do run tests to make sure that we are up to date with the module spec, Jigsaw and the JPMS. We also support Endpoint Discovery. So this is a new feature. It's also available in V1 of the Java SDK, and you're going to see it rolling out to a lot of our other SDKs. We've never really done a big marketing push here, so I kind of wanted to explain what this does. When you're typically doing service-client interaction, when you're working with one of our services, you're typically communicating over an endpoint like that. It's the service.region.amazonaws.com. And so you're going to do a DNS resolution on, say, something like s3.usc1.amazonaws.com. And that's a global pool, right? Everyone is going and getting data from that same pool. Whereas with Endpoint Discovery, it's an option for a service-client interaction for basically the service can tell the clients, instead of using service.region.amazonaws.com, make your communication more like this, to where I can have customer-based endpoints, I can have something like resource-based endpoints. If you have 5 or 6 different resources, each of those can have a separate endpoint. The service can then take that endpoint, and route that traffic, more intelligently or more performant. So you're going to really get greater resiliency. Depending on the service, you might even get greater performance because they might be removing out some intermediate network hops that aren't possible with that global or that regional endpoint. And
this is something that the SDK handles for you, kind of managing these URLs.
Yeah, so you don't have to do anything. You do, for many clients, this isn't enabled by default because, again, we don't want to break you. If you're using that standard regional endpoint and you have rules, never rules against this, we don't want to break you. So if you see this as an option on clients, definitely enable it, definitely test it out. It's never going to, it should never make things worse for you. It's going to always give you that greater resiliency. And depending on the service, it might give you actually quite a bit better performance as well.
And what services?
So DynaDB supports this today, and you're going to continue to see this roll out to more services as they onboard. And then the other big thing that we have now in SDK v2, which we think is going to unlock some new capabilities, is HTTP2 event streaming. And what this is it's fully non-blocking HTTP2 clients. It's built on top of our async netty client. And it allows full duplex bidirectional real-time streaming. So you can do both asynchronous non-blocking streaming requests to the service and get back streaming responses from the service as well. And so we look at this ecosystem overview here. We kind of had streaming in V1 with the Kinesis producer library and the Kinesis consumer library. But those were pretty much just buffering request response types replies underneath to kind of fake that streaming experience. Whereas now we can really add that bidirectional streaming process here. And so let's take a look at what that looks like. We do have 2 services today that support the HTTP2 spec. There is Kinesis, which supports streaming responses, and then there's transcribe streaming, which actually supports that bidirectional streaming of responses. So I'm going to take you through a demo of what that looks like today. So here we're using the Java SDK. Like I said, we're going to go ahead and create a transcribe streaming client. Again, we're going to go ahead and just use that create method, which IntelliJ automatically detects, to create the client. And then just to show where we want to end up, so we want to end up with this call here, start stream transcription. So IntelliJ is going to tell you there, you need a request object, you need a publisher of audio data, so that's going to publish data to transcribe, and you need that response header to handle back those asynchronous responses. So let's go ahead and create this out here. So we're going to create this request object. And again, what you might notice is IntelliJ automatically detects that builder pattern, so it's going to automatically show you that builder and the build method there. So let's go ahead and create this object here. So again, I'm speaking English, so we're going to tell it that I'm speaking English. We're going to encode in PCM audio, and we're going to sample at 16,000 hertz. You don't need to be super familiar with those, how those work. It's just simple audio processing. So that's my request object. And then so you need to start sending data to transcribe. And so in a common case, you can send it a file, you can send it audio files, you can send it videos, and it's going to start transcribing those videos. But we're here live at reInvent, I'm here on stage. And so let's try and see if we can get just a live transcription of me as I'm talking here on stage. So I'm going to use the target data line class. It's a JDK class just for working with audio. And I've got a simple class set up to recognize my max microphone here. And then we're going to go ahead and start that. And then again, built into the SDK, we have this audio stream publisher class. And it takes an audio input stream, which again is built in the JDK, and you can pass that target data line right to an audio input stream. So that's my publisher of data. So the last thing I need is that response handler to be able to handle those streaming responses as they come back in. So let's go ahead, and again, we provide those interfaces in the SDK to make it easier for you. Again, the IntelliJ is going to detect that builder pattern. So to really show off the power of this HTTP2 event streaming, I'm going to show you, I'm just going to do a simple subscriber here that prints out all the events coming in, which you'll see later. You can actually filter that down if you want, and I'll kind of show you what that looks like. So I'm going to cast this to a transcript event because you can have multiple types of events. In this case, I do want that transcript event. And so on this object, you've got your transcript. It's got a list of results. And let's just go through each one of those results. And so on here, you're going to see it's got an end time. It's got an is partial. It's got a result ID. So if you want to, you can actually filter that down. If you're doing something like a closed captioning system for TV, you can use those objects to kind of filter that data down to just what you want. But again, I'm just going to go through, and I'm going to print out everything so you can really see the power of this. So let's just do a simple, print this out to the line. So that's my response handler. Let's go through and plumb all this into my request.
So this is going to listen to the microphone on the laptop.
Yes.
And send it up to transcribe.
Asynchronously, non-blocking.
Give us responses back with the transcription.
Yes.
Hopefully.
And so this is a completable feature, so I'm going to go ahead and call join. And so again, you're looking here at about 21 lines of code. So very, very small amount of code here. We can go ahead and run this. And so you're going to see it's going to take a second to buffer here, but very quickly we're going to start getting back this response from transcribe. And as I keep speaking, now that it's fully buffered on this connection, right, you're going to continuously get this data back from transcribe. And again, this isn't us, making request responses for you underneath the hood. This is just a single continuous HTTP2 connection, non-blocking, and I'm just sending that data to transcribe, and it's sending it back. So you're really going to get that high throughput. You're going to get that high concurrency because, again, this is just a single connection that allows for really high throughput. I'm really excited for where this is going to go. You're going to see existing services move their streaming type responses to this, and you're going to see new AWS services come out like this. I'm waiting for the day where, as much as we try and Americanize my coworker here, the one nice thing about him is his Australian accent. So I'm waiting for the day where I can use something like transcribe and another AWS service to do, convert my boring American accent into a nice, Australian accent like my friend has here.
I don't know that it's that nice.
So just kind of wrap up because I've thrown a lot of information your way. We are GA as of 11/19. You can find us on GitHub. Again, so we're open source like everything we're talking about here today. If you have any feature requests, issues, bug reports, if you want to submit code to us, you can find us there on GitHub. Our developer guide is available, so if that's where you're going to want to start, if you're a new user, you can start the developer guide, and it's going to have all the information you need to start. The KCL 2.0 is available now, so if you do want to use that streaming on Kinesis, you can use that KCL 2.0, and it'll support the Java SDK v2 underneath, and you can also find them on GitHub. And then our high-level libraries are coming soon. So right now, we mostly just have the low-level clients for all of our services. We're going to bring back, S3 Transfer Manager, manage multi-parts, uploads, downloads. We're going to bring back that ORM for DynamoDB, the document model, IAM policy generation. If you run an API gateway, you might notice that you can actually generate a Java SDK for your API. That's actually owned by my team as well. And so we'll bring the Java SDK v2 to that as well. So if you have an API gateway API, you can get a Netty asynchronous client for that as well. And then more with your feedback. So even though the ones I listed here, we're an open book right now. As far as prioritization goes, as far as what new features go, that's all going to be based on your feedback. We've got a lot of it from our V1 repo. But we're always looking for more feedback of what you guys want to see in the SDK to really help make some of those services more dynamic, more features, more easy to use. So now I'm going to hand it back to my co-presenter here, Kyle, to talk about infrastructure and code.
OK, so infrastructure and code. Before we talk about what that looks like, I want to kind of take a couple of steps back here to the AWS Management Console. Now, who here has used the web console before? So it's a great way to understand what AWS services are available, how you can configure them, what their capabilities are, and create simple applications. But as soon as you need the ability to kind of replicate what a set of infrastructure looks like across multiple accounts, or you want to be able to source control something so that you can reliably recreate it over time, or you want to have multiple environments, multiple regions, you need to kind of graduate from manually creating resources in the console through the web console to something like CloudFormation. So again, who has used CloudFormation before? OK, great. So CloudFormation is AWS's infrastructure deployment engine. And it allows you through a declarative language to be able to state what you want your end state of resources to be. So you list out all of the infrastructure that you require for a particular application. You configure it using YAML or JSON syntax, all of the parameters, what their interactions are, and how they work together. And then you hand that template to CloudFormation, and CloudFormation manages the deployment of that infrastructure for you. If you're doing a brand new stack, then it's going to go and create all of those resources. But it also has the ability to apply differences to an existing stack. So because it's declarative, you define what you want your end state to be. You pass that template across to CloudFormation, and CloudFormation will generate a change set and apply the differences only. So resources that you've removed will get removed from your account or from your stack. Things that have been updated will get updated, and things that are new will be recreated. But you're not starting from scratch every time. CloudFormation has the ability to kind of manage that process for you. Now, the fact that the syntax for declaring templates is in YAML or JSON means that they can get rather large. JSON is something of a verbose syntax. And on top of that, you don't really get any help in terms of integrated IDE help for figuring out what properties go with what resources. So it's a lot of kind of reading the documentation, figuring out what properties you need to set on each resource and what format that might take, and then including them in your template. Also, if you want to kind of share subsets of a template around a team, so let's say you had a particular auto-scaling strategy that you wanted to apply to multiple tables, without copying and pasting and templatizing, that's kind of difficult in JSON and YAML. So that's where the AWS Cloud Development Kit comes in. Who's heard of Cloud Development Kit or CDK? OK, not too many people, great. So CDK fits very much in the client-side build tools section of this diagram. It is a CLI that you install on your local machine. And what it gives you is the ability to represent resources in plain Java code. So CDK allows you to create resources just using regular Java code, and we're going to see an example of that in a minute. But it's more than just low-level resources as code. CDK also gives us some access to higher-level abstractions that are created as part of CDK. So very commonly, there are multiple different resource types that get used together. Now, if you think of DynamoDB as an example, if you want to enable auto-scaling on DynamoDB, in a CloudFormation template, you need to create the table. You need to create a scaling rule. You need to create an alarm for that rule when the threshold is met, and then handle that event in terms of scaling up or scaling down. There's multiple resources that you need to create in order to be able to have that auto-scaling capability. With CDK, we have created a number of high-level abstractions over common patterns like this and made them available. So, and we're also building an ecosystem around this in terms of the CDK construct gallery, which is kind of a community-owned collection of similar abstractions like this. So it's object-oriented. It's you're writing Java code. You can compile this code into a jar file, put it in an artifact repository, and share it among teammates. So it makes it really easy to extend and share common features that you want to use across your company or across teams. Now, because it's Java, you have obviously that IDE support. And so this isn't something that you need the AWS toolkit for JetBrains for example. Because it's just plain Java, you have that ability to kind of inspect the code as you would any IDE, and we're going to see an example of that in a minute. Again, like we said, like everything that we've talked about this afternoon, this is an open source product. It's currently in developer preview, which is why now is a really great time to go over to that GitHub repository, see what's happening, give your feedback, plus one thing. Now is the perfect time while we're in developer preview for us to make changes, and we really want to get feedback so that we understand we're moving in the right direction.
And what's our language support?
So at the moment, we support JavaScript, TypeScript, and Java. The plan is to roll out to all of the language bindings that the SDK supports. So as Sam mentioned, the AWS SDK is vended out in 8 different languages. The idea is that CDK would also be supported in those languages. So let's take a quick look at a Java example. So I want to create a new stack that has an SNS topic subscribed to an SQS queue. Now in CDK, what I'm going to do is I'm going to go ahead and create those 2 resources, and it's simply newing up a couple of classes here. So I'm newing up a queue object, I'm passing it some properties, I'm giving it a name, and then I'm newing up a topic object. Now, you'll notice that queue properties and topic properties are specific to that resource type. So you only have the ability to set things on there that are actually defined as part of that resource spec. And so you're going to get help with the IDE. You're going to get compile time checks that this thing is the correct type, which allows you to really get a much faster feedback loop than if you were using, say, a JSON document that doesn't have this kind of validation. In that case, you kind of have to do the deployment, understand what you missed as part of those properties or what those properties might be called, and then iterate that way. This way, it allows you to shorten that development time. You really get that feedback loop much faster. You get it as part of the compilation. But we've got a queue and a topic here. And what we really want to do is we want to link these things. And this is where the higher level abstractions really comes in. So I'm going to kind of drop into an IDE view here. And I'm going to play this video. I kind of cheated here. So I'm going to look at the topic object. And again, so I'm in the IDE here. So I have the ability to kind of see what is available on that object and explore the interface. So I see a subscribe queue, which takes a queue object, a typed queue object. Again, the compiler is not going to let me pass an S3 bucket to the subscribe queue call. It's a type-checked thing that we get as part of the compiler. So by making that call here, I've got 3 statements of CDK code to create the infrastructure that I'm looking for. Now, CDK is not a replacement for CloudFormation. We still use CloudFormation under the hood to take care of that deployment, because that's what it's really good at. It's a powerful deployment engine, as I talked about, in terms of being able to understand what changes you've made to your stack and apply the appropriate differences. So to be able to actually get this thing into my AWS account, I need to, using the CDK CLI, synthesize this into a template. So I've done that already, and this is the template that gets configured. Now, it's pretty big. It's actually split across 2 columns here so that I can fit all on one slide. So what I want to do here is kind of collapse some of the properties so that we can see really what's going on here. And you can see we've got 4 top-level resources having been created here. Of course, we've got the queue and the topic and the properties that we set on those as part of my construction. But I've also got this queue policy over here on the left-hand side. Now, CDK can understand the syntax tree and understand how you're using your resources and defining them and how they interact together. So by virtue of the fact that I've called subscribe queue on that topic, we know that the queue needs to have a certain policy in order for that interaction to work. And CDK can infer that policy for you. And then, of course, we have the actual subscription itself. So there you have a fairly simple CDK example, but hopefully it shows you kind of the power that you can get by modeling your infrastructure in code instead of using pure YAML or JSON syntax. So if this is interesting to you and you kind of want to learn more, this morning there was a breakout session, but that'll be up on YouTube later on in the week. If you missed that or you kind of don't want to wait for that to come out on YouTube, we have some chalk talk sessions around CDK both tomorrow and Thursday. So this is going to be a really hands-on session. It's going to go into much more detail about the power of CDK. and the things that you can do with it. So the final thing I want to talk about this afternoon is in our execution environments area. Who has heard of Amazon Careto? OK. So a couple of weeks ago at DevOps, James Gosling announced Amazon Careto. Amazon Careto is an Amazon-supported open JDK implementation. Now, this is a JDK implementation that is not just for use on AWS infrastructure. It's something that you can download. It's multi-platform. We currently support Mac, Windows, and several Linux variants. And it's free. And we have long-term support for Careto 8, which is the Java 8 version, through until 2023. Careto 11, which is the JDK 11 version, through till at least 2024. That may move out. This is currently in developer preview, but it is production ready. We use a version of Amazon Careto internally for thousands of services in AWS, so it is battle hardened, it's production ready. And our expected GA is in Q1 next year.
And what is Careto for those of us that aren't coffee drinkers?
So Java is a type of coffee, and we decided we wanted to build on that, but make it a little bit Italian. So Careto is an Italian word for a shot of coffee with usually a little bit of alcohol in it, like brandy or schnapps. So what we like to say is, and actually it was James Gosling who termed this, it's Java with a kick. So it's open source. And again, if you want more information, then you can go to the documentation website there. But I guess just to reiterate again, this is a free multi-platform open JDK implementation supported by Amazon. OK, so we kind of threw a lot of stuff at you there. And I want to make sure that we kind of hit the big topics here just to kind of do a quick recap. So we started off with looking at serverless deployment and local debugging of Lambda functions in the IntelliJ toolkit, the JetBrains toolkit for AWS. Sam then took us through a recap of some of the new APIs and programming paradigms that you're going to see in V2 of the Java SDK. He took us through, again, some of the improvements that have been made to the SDK to improve that startup time so that for customers who are using short-lived applications like Lambda are really going to be able to take advantage of that. We saw that awesome full duplex streaming demo of Transcribe where we're pushing audio up and real time on a single HTTP connection, getting the transcriptions back. We looked a little bit at infrastructure as code and being able to model a simple stack and kind of having the power of having a language define your infrastructure. And then we talked about Amazon Careto, the Amazon-supported open JDK implementation. So one more thing I just want to plug before we wrap up. If you're interested in serverless or DevOps or containers or microservices, I strongly suggest you check out this session on Thursday afternoon after the Werner keynote over in the Venetian. This is going to be run by the VP of Serverless for AWS and the Director of Builder Tools, who both Sam and I report to. He kind of owns all of the SDKs and a lot of the client-side stuff that we've talked about today. So check out that session. It's your opportunity to kind of find out what's going on in those areas. And with that, I'd like to say thank you very much. And we will be down here by the stage if you have any questions afterward.